Hello, hello. Hello, hello. Okay, dear student, please confirm. Audio and video is clear or not? Tell me. Audio and video is clear or not? Please confirm in the chat box. Audio video is clear or not? Hello, hello. Hello, hello. Everything is clear. Yes, thank you. Okay. Now, today we will discuss the most important questions based on the signaling system. Okay. And these questions are helpful for CIL examination. Everything is clear. Okay, okay, Satish. Okay, thank you. Now, first of all, we discuss the syllabus, which are the important topic. Today we will discuss the important topic for CIL. First of all, we discuss Laplace transform. Okay, Laplace transform. Laplace transform, we write as Laplace transform. And second is CTFT. CTFT is important. And basic signal classification. Basic signal and system classification. System. Okay. These are the important topic, and CTFS, continuous time Fourier series, is also important, and DTFT is also important, but in the previous examination only Z transform is important. Now we discuss here all the related things, then we proceed further. See, first of all, we discuss the Laplace transform basic. Here we discuss all the prerequisite for solving the questions, then we solve the questions and everything is clear. Okay, beta. Okay. See, this is the in tabular form all the formulas of the Laplace transform. These are the xt and this is the x of s. Laplace transform is a mathematical tool which convert time domain to frequency domain. Okay. See, this is the signal del t. Del t is impulse signal, and here magnitude is 1. That is why it is said to be unit impulse. And Laplace transform of 1, ROC, entire S plane. We fastly revise all the formulas. And del t minus t naught, this is the shifted version of impulse, a to the power minus s t naught, and t naught greater than or equal to 0. Here ut, unit step, 1 upon s, ROC mentioned here, AUT, a upon s, TUT, 1 upon s square, t to the power n ut, n factorial upon s to the power n plus 1. Next, t to the power n upon n factorial ut, this. Now, a to the power minus 80, this is very, very important, yeah, these two signals. A to the power minus 80 ut, 1 upon s plus a, ROC, real part of s greater than minus a. Next, e to the power 80 ut, 1 upon s minus a, ROC greater than a. These all the important formulas. Okay. Now, these are also important. Now we discuss the questions related to that particular. These are the properties, yeah. we mention all the properties like linearity property, a x1t plus b x2t equal to a x1s plus b x2s, and the ROC is the intersection of both the ROCs. Okay, this is the time shifting xt minus t naught u t minus t naught equal to e to the power minus st naught xs. We discuss one by one with the help of formulas. Okay, see, these are the properties. Now we discuss the questions. These are the important agenda. See, first question. First of all, you tell me in the comment box. Satish, Sarthak. Yes, B. 1 upon S. And ROC? ROC real part. See, S equal to sigma plus J omega. But in ROC, we consider the real part. So, real part of S for this signal, real part of S, or we can say sigma is greater than 0. This is the ROC. Next. This is the explanation. Okay. The unit step signal UT is defined as T. First of all, we write here UT is defined as 1 t greater than 0 and 0 t less than 0. And this is the UT. This. Okay. These are the explanation of UT signal. Now, the Laplace transform of e to the power minus at ut. Tell me. Yes, Sarthak. Good. Akash Gupta. Sarthak. Okay, Satish. Answer B. Okay. 1 upon S plus A. 1 upon S plus A. Yes. And ROC? With ROC. Please answer each and every question with the help of ROC. What is ROC of that signal? Sigma greater than minus A. Yes, Sarthak. You are right. Now see here. These important signal here. E to the power minus at u of t. Laplace transform is 1 upon S plus A, and ROC sigma greater than minus A. Now tell me, what is the Laplace transform of that signal? E to the power minus at u minus t. Tell me, what is the Laplace transform? This is said to be Laplace transform pair, LTP. Laplace transform pair. Okay. Now tell me, what is the Laplace transform of minus e to the power minus at u of minus t? Tell me, Saurabh. Sarthak, Akash. 1 upon S minus A. Okay. Anyone? Tell me. But these signal also same Laplace transform. But ROC is different. Okay. ROC is different. If we draw the ROC of that signal, this is the sigma. Okay. And this is the j omega. Okay. First of all, we mention that signal. Okay. E to the power minus at ut. Sigma greater than minus A. Okay. Minus A like. This is the line. Sigma equal to minus A. So these are the vertical line. Okay. Above minus A. This is the part of ROC. Like that. Okay. These are the part of ROC. If we consider next. This is the explanation, all the things. Causal signal e to the power minus at, the Laplace transform of calculated using the standard definition. Okay. See this question. If x of t having the Laplace transform of x of s, then the Laplace transform of dy by dt xt. This question is related to differentiation property. This property, differentiation property. Yes, B x of sxs minus x0. Yes, this is the right answer. Yeah, right answer. C. dy by dt x of t equal to s xs minus x of 0. Yeah, x of 0. Now, if we write the property d square y by dt square xt, then tell me what is the formula of that? S square x of s minus s, okay, s, tell me, x0 minus x dash 0. Okay, this is the property. Okay, like that. Now next, this is the explanation of that property and where we can apply. Next, the region of convergence of a causal right-sided signal is generally, tell me, simple question, statement type. And in the 2017, most of the question asked based on that particular topic. Tell me, Sarthak. Question number 4. The reason of convergence of causal right-sided signal is generally right-sided signal. B, yes, right of the rightmost pole. Very good, beta. Very good. Okay. For the causal or right-sided signal, the signal exists for t greater than equal to 0. Okay. In Laplace transform analysis, the reason of convergence depends on the nature of the signal and pole location. For right-sided signal, the ROC lies to the right of the rightmost pole in the S plane. This is because convergence requires the exponential term e to the power minus st to dominate the growth of the signal as t tends to infinity. ROC does not include any pole. This is the basic property. This concept is essential for identifying whether a system is causal or stable using its pole zero plot and transfer function. These are the explanation. Now next, fifth question, a continuous time LTI means linear time invariant system is stable if the ROC of its system function includes, very important, fifth B, Sarthak, okay, yes, imaginary axis. This is the right answer. Next, this is the explanation. Sixth question. Tell me if f of s equal to, this is the our given function. Okay, equation number 1. Now then the initial value f0 plus is, here we apply initial value theorem. Initial value theorem. Tell me. फिफ्थ का बी सार्थक, टू आंसर ए एंड बी बोथ आर द करेक्ट. अच्छा, ओके, आकाश, सार्थक 5, फिफ्थ का बी, आकाश ए, सी. ओके, here final value, initial value, okay, initial value C. What is initial value theorem? Initial value theorem. Initial value theorem. See, initial value theorem, first of all we apply if the function is strictly proper function. Okay, proper means numerator has the degree less than the degree of denominator. Okay, this is the improper function. Now x of 0, okay, x of 0 plus equal to limit s tends to initial na, limit s tends to infinity, s of x of s. Here Fs given, so we put in place of Xs Fs. Now limit s tends to infinity. What is the function? S function is 4 upon s plus 3. 4 upon s plus 3. This s is cancel. 4 upon s plus 3. Putting the s equal to infinity, then we get 0. This is the answer here. Okay. And Akash Gupta. Okay, Sarthak. Okay. Right. 0. Okay, 0 answer. This is the solution. Here we also mention. 7 question. If f of s equal to this, then what is the final value? What is the final value? Tell me. सेवन का सी. ओके. आकाश गुप्ता 7 का सी. सार्थक 7C. Anyone? Okay, see. What is the final value theorem? What is the final value theorem? See. Final value theorem. Final value theorem. Okay. What is the necessary condition for final value theorem? All the pole of S into XX strictly lie on the left half of S plane. Okay. This is the mandatory condition for final value theorem. Again, we repeat. Mandatory condition for final value theorem is that all the pole of S of Xs, S into X, all the poles of S into X of S lies strictly left half of it, in the left half of S plane. This is the mandatory and necessary condition for final value theorem. See here. Here, first of all, we write the final value theorem. X infinity or steady state value, both are the same thing. Final value and steady state value, both are same. Limit s tends to 0 s xs. Okay, this is our condition. Here in place of xs given fs, 8 upon ss plus 2. See, limit s tends to 0 s. What is the xs or fs? 8 upon ss plus 2. 8 upon s plus 2. S cancel out, and putting the remaining term s equal to 0. 8 by 2, that is 4. Okay. So C is the right answer. Okay. Right. C is the right answer. Okay. If you face any difficulty, you want to discuss many things like related to initial value, final value, whatever we study here, then please discuss with me with the help of chat box. Next, the initial value theorem. Simple question. Tell me. Sarthak, tell me answer of that question. Initial value theorem. Initial value. Yes, B is the right answer. S tends to infinity. SFS. Tell me. If f of s is equal to this, then final value. Final value. Tell me. Important question. Question number 9. Tell me. Question number 9. What is the answer, Sarthak? Akash? Not applicable. Okay, not applicable because roots of S into Fs lies on the imaginary axis, and the mandatory condition is that all the pole of S into Fs or S into Xs, both are the same thing, strictly lies on the left hand of S plane. Okay, left half of S plane. So that is why it is not applicable. Next. Now find the, this is the question, and option initial match the correct option. Lies on imaginary axis. Yes, yes, Sarthak. Right, good. Ten ka A. See, first of all, we find the final value. Final value. Final value x of infinity equal to limit s tends to 0, s tends to 0, s of fs, okay, see 12 upon ss plus 4, limit s tends to 0, s 12 upon s, s plus 4, s plus 4, ss cancel, s equal to 0, then 3, and this is the f infinity means 3. This is the right, yeah, this is the right. Now we find the initial value also. Initial value x of 0 plus equal to limit s tends to infinity, s tends to infinity, s of fs, okay, then limit s tends to infinity, s into 12 upon s, s plus 4, then ss cancel out, then this comes out to be 0, initial value 0. So initial value, okay beta, B is the right answer na. Madhuri Dipankar, the why you mark the A? Okay, this is the final value na. Final value is 3, but initial value is comes out to be 0 na. Tell me, where is your doubt? Please thumbs up if this concept is clear. Initial value and final value. Akash, Sarthak and Madhuri Dipankar, please write the on comment box, okay, if you face any difficulty. Many questions we discuss with the help of MCQs on the initial and final value theorem. Okay, Sarthak. See, the response, very important question here. Here, many students are confused, but in today's lecture, we discuss all the doubts related to response of the system. See, the response of a system due to both initial condition initial condition and external input is called? Tell me. Question number 11. What is the answer here? C. Total response. See, total response equal to natural response plus forced response. Okay, forced response. This is the important. Total response equal to natural response and forced response. Okay, this is the important. Okay, so both initial condition and external input, total response. But here we discuss the what is the natural response and what is the forced response. See, natural response. Natural response. Natural response. Anyone tell me what is the meaning of natural response? Anyone please write on the comment box. What is natural response? See, this is the response of the system due to system's pole or transfer function poles. Okay, means anything. Okay, we applied as an input or response, then transfer function also there like that. See here, this is our transfer impulse response like st. Okay beta, and this is our input x of t, and this is our output yt. What is the relation in these quantities? See, yt equal to x of t convolution h of t. Okay, when we take the Laplace transform, convolution converted into multiplication. So y of s equal to x of s, okay, into h of s. Okay, this is. Then this is the system function or transfer function. See this. The output that is ys due to the portion is said to be natural response. Clear or not? Tell me. Natural response is clear or not? Natural response is clear or not? Okay. Okay. Now, natural response. First is natural response. See, next forced response. Second is forced response. See, this is our transfer function. See, and this is the input x of t in the Laplace domain xs. The output that is ys due to this input poles. This is said to be forced response. Okay, this is the forced response. Response due to the input. Okay, due to the input. This is said to be forced response. Now next, which response depend only on the initial stored energy of the system? Tell me. Initial energy stored. Initial energy stored like that in the system's poles. due to the system pulse. Yes, natural na yaar, natural. Okay, yes, natural response. Now, here also we explain other classification of response, total response. Beta, up to now we discussed that total response equal to natural and forced. Natural means due to the system pulse, forced response means due to input. Okay, now see here. Okay, total response equal to, here actually we respond due to the input pulse. This is important, yeah. Input pulse, this is the important. Now see here, total response is also classified like that. See, zero input state, zero input response, zero input response, zero input response, ZIR, plus zero state response, that is zero state response ZSR. What is the meaning of that term? Yes, both is total response. Yes, forced and natural. Yes, beta. Yes, Madhuri. See, here we classified, but here zero input response and zero state response, the sum of that two response is the total response. Okay, but what is the meaning here? Zero input response. See, ZIR we write as ZIR, zero input response, due to input. IP means input, beta, due to input, but initial condition zero input. No, this is the mistake. Due to zero input means input zero, na. See, we correct it. Due to initial condition, but input is zero. Next, zero state response, due to input only, but initial condition is zero. Okay, beta. Now, these four type of response we discussed here. See, the response that remains after the transient part disappears is called. Okay, this is also the classification of response. Transient in steady state, 30 day, yes, day. Okay, steady state. Transient means fluctuations or temporary response. And usually total response also classified as the sum of steady state and transient. And transient is that part of the total response which goes to zero when time approaches to infinite. And steady state response is that part of the total response after transient has died out. This is the meaning of it. So steady state response is the right answer here. See, after sufficient time, the transient response dies out and the remaining response is called the steady state response. Next, in a stable system, the transient response. Sir, how we can get the PDF? But in the given Google form and the WhatsApp link, please you can join the WhatsApp group, okay, according to your branches, okay, and you get the PDF on that particular group. Okay, Sartha? This is clear? Now tell me, in a stable system, the transient response. See, we plot 4 options. This is any signal xt, or we can say st, impulse response st, and this is the t, like that. Okay, increasing. And this is other h of t with respect to time, like this, decreasing. What is this? Is the A system, this is the B system. System A is stable or B is stable? Tell me. System A is stable or B is stable? Tell me. See beta, if transient response decayed with respect to time or exponentially decreasing, and when time tends to infinite, it becomes zero, then this system is said to be stable system. Okay, so this is the stable and this is the not stable. In 2020 paper CIL, this condition also asked. Okay, what is the condition of stability? Actually, this question asked in the discrete domain, absolutely summable impulse response for discrete time, and for continuous time, absolutely integrable. Okay, this question we solved in the same platform. B is approaching to 0. Yes, Sartha. Stable for stable. B remain constant. No. Increase continuously. No. Decay with time. Yes. This is the right answer of that question. Na? Please tell me, beta, this concept you can understand or not? Next. See, this is the explanation. Decays with time. For a stable system, transient components gradually reduce to zero as time increases. Next, the output produced by a unit impulse. Unit impulse input is known as, means if we apply as an input unit impulse as an input, then what is the response? Means output is said to be. What is the name? Step response, ramp response, impulse response, frequency response. Tell me. Tell me. Impulse response. Okay, unit impulse, na? Input is impulse. Okay, yes. Impulse response is the right. If we apply step response, then we get step response. If we apply ramp input, then we get ramp response. Okay? This is the proper explanation. When a unit impulse input is applied to a system, the resulting output is called the impulse response. It represents the system's behavior and characteristics and is widely used in signal processing and control system analysis. Tell me. Actually, here integration sign is missing. Actually, this is the integration, and this is also integration. This is also integration. Okay. So this is okay, clear. Integration minus infinity to infinity xt to the power minus j omega t 0 to infinity. The continuous time Fourier transform CTFT of the signal xt. Any signal for xt, what is the continuous time transform? A, yes. See, Laplace transform of xt. See, x of s equal to minus infinity to plus infinity x of t e to the power minus st, okay, dt. This is the BLT, that is bilateral Laplace transform. Beta. Bilateral means both sided, minus infinity to infinity. Na? If xs equal to, this is the first formula, this is the second. 0 to infinity x of t e to the power minus st dt. This is the ULT. ULT means unilateral Laplace transform. And what about Fourier transform? See, Fourier transform, or we can say continuous time Fourier transform. Continuous time Fourier transform of x of t, comma, x of omega, or we can say x of j omega equal to minus infinity to plus infinity x of t e to the power minus j omega t dt. Here no concept of bilateral or unilateral. Okay. So our answer is A. Yes. This is the explanation. This is here the integration sign. The inverse CTFT is represented by, here also integration sign missing. We mark here. Okay. Tell me. Sixteen, 17. Sarthak, Madhuri, Uday Kumar. Tell me the B or A or C or D. Madhuri, yes, B. B is the right answer. See, x of t equal to inverse Fourier transform 1 upon 2 pi minus infinity to plus infinity x of j omega, or omega e to the power j omega t, okay, d omega. This is the right answer of inverse Fourier, inverse continuous time Fourier transform. Okay, beta. So the inverse continuous time Fourier transform of this. Okay. Next, the CTFT of unit impulse. Tell me. CTFT, Laplace transform, all the transform of impulse are identical or the same. Tell me. 18. What is the answer, Madhuri, Sarthak, Uday? Tell me answer. Yes. What is the answer? Yes, 1. See, Laplace transform of del t is also 1. CTFT of del t is also 1. Z transform of del t is also 1. DTFT, discrete time Fourier transform of del t is also 1. Okay. This is clear or not? Next. The CTFT of constant signal 1, this is very, very important. Yeah, very, very important. Tell me. See, yes, beta, yes. The transform CTFT of 1 is 2 pi del omega. 2 pi del omega. Yes, this is the right. Now, see here. One is property, frequency shifting property. X of t e to the power j omega naught t. What is the Fourier transform of this signal? What is the Fourier transform? See, Fourier transform is x omega minus omega naught. This is very, very important property. Frequency shifting property, beta. Now see, some important conclusion. 1 into e to the power j omega naught t. Here x in place of xt is 1 and Fourier transform of 1 2 pi del omega. Then if we multiply exponential e to the power j omega naught t in 1, properties allow. Okay, see. Then this Fourier transform is 2 pi del omega minus omega naught. Okay, my dear. See. Now next 1 into e to the power minus j omega naught t. What is the Fourier transform? That signal 2 pi del omega plus omega naught. Okay, see. This is clear or not? This is clear? Yes. Now beta see cos omega t. Cos omega t we also write as e to the power j omega t minus e to the power minus j omega t. Okay, e to the power j omega t. Actually this is plus upon 2. If we want to find the Fourier transform of cos, then we apply e to the power j omega t. See, e to the power j omega t, or we write as omega naught here, so that we not confuse in the omega and omega naught. See, this is omega naught t. This is omega naught t, and this is omega naught, and this is omega naught. Then tell me, what is the Fourier transform of cos omega naught t? See, cos omega naught t having the Fourier transform, see, e to the power j omega naught t, see, e to the power j omega naught t 2 pi del omega minus omega naught. So we write here 2 pi del omega minus omega naught. Okay, and e to the power minus j omega naught t plus 2 pi del omega plus omega naught, and divided by 2. So divided by 2, and 2 to cancel. Then what is the exact formula? Pi del omega minus omega naught plus pi del omega plus omega naught. Okay. Now this is clear. This is the very important result. And our detailed course we discussed these all the shortcuts here. If you face any difficulty up to now, then please discuss with me. Sarthak, Madhuri, Uday, tell me. This is clear or not? This is clear now? Now. Time shifting property of CTFT states. Time shifting property. Clear. Okay, beta. Thank you. A xt minus t naught. Yes, right. See, time shifting property x of t minus t naught having the Fourier transform, if we write in proper way like that, see, time shifting. See, if x of t having the CTFT x of s, then x of t minus t naught having the CTFT a to the power minus st naught x j omega or omega, both are the same thing. Okay. Yes. Then xt plus t naught having the CTFT continuous time Fourier transform a not the s. Okay. Here we correct e to the power j omega t naught. Here e to the power plus j omega t naught x of j omega. Okay. This is clear now? Next. Okay, this is the very important time shifting property. Frequency shifting. Tell me. A, yes, right. Yes. Here we also discuss na frequency shifting property and time shifting property. Very, very important property. Yeah. See this. Okay. X omega minus. This is the frequency shifting property. Now we discuss frequency shifting. This is clear. The convolution property of CTFT is. This is also important. Convolution in time domain, time correspond to multiplication in frequency. Tell me. Yes, Abhishek. A is the right answer. Okay. What is the property C? Okay. x1t convolution x of t having the CTFT x1, not the s here, because here this we study the Fourier transform x1 j omega into x2 j omega. Okay, or we write as x1 omega into x2 omega. Both are same. Okay, so A is the right answer. Parseval theorem for CTFT represent energy conservation between time and frequency domain, signal periodicity, differentiation property, time scaling. This is also important property, yeah, Parseval's theorem. Yes, A beta. Okay, A, energy. Okay, this is the formula. Energy of time domain and energy in frequency domain. This is the equivalence. Okay, an important property. Yeah. If xt is even signal, then Fourier transform. Tell me. If xt is a even signal, question number 24. Tell me. Real and even. Yes, real and even. This is the right answer. Okay. The CTFT exists if the signal satisfies. This is the very important question, yeah. Okay. Dirichlet condition, Ohm's law, Kirchhoff's law, Nyquist theorem. Real and even. Yes, beta. Madhuri, you are right. A, yes, Dirichlet condition, yeah. Very important. Dirichlet condition. Okay, these are the Dirichlet condition. A signal must satisfy Dirichlet conditions for Fourier transform existence. Signal should be absolutely integrable. Finite discontinuities allowed. Finite maxima and minima allowed. These conditions ensure convergence of the signal. This. Okay. A signal xt is periodic if, tell me, any signal is said to be periodic if x of t equal to x of minus t, xt plus t equal to x of t. Tell me, 26th answer. Yes, B is the right answer here. And this is for all t. For all t. Next. Determine the fundamental period. This is a very simple question here. Fundamental period. Tell me, 27th. Okay. Compare standard form t equal to 2 pi by omega. Here omega equal to 4 pi. 2 pi upon 4 pi, that is 0.5 second, because time, standard unit of time is the second. So B is the right answer. Which of the following signal is not periodic? Sin 2t, e to the power jt, ut, cos 5t. टेल मी. And we write here very important point. Yes, UT. Here we write one note. See, all exponential are non-periodic, but all complex exponential exponentials are periodic. ओके, देखो ये एक्सपोनेंशियल है ना, तो दैट इज व्हाई दिस इज पीरियोडिक. बट e to the power 2t 3t, these signals are non periodic. Tell me, a discrete time signal x of n is periodic if 29. Yes, A is the right answer for all small n. The signal xt equal to cos tan t plus pi has a fundamental period of tell me. A. Yes, 2 pi by omega is 10, so pi by 5 is the right answer. Yes, this is the explanation. A signal which satisfies xt equal to x of minus t, odd, periodic, even, non-periodic. Tell me, what is the answer of 31? C, even. Yes, right, even signal. Okay, these are the example. A signal satisfies xt equal to minus of xt. This is the ODR. Simple. This question is simple. Which of the following signal is an energy signal? Tell me. Periodic sinusoid signal, constant signal, finite duration pulse, step signal. Which of the following is an energy signal? Periodic sinusoid, okay, constant signal, finite duration step signal. Question number 33. Yes, finite duration pulse. Right, Madhuri. This is the formula of energy signal. But some point is also remember. Okay. Energy of power signal infinity and power of energy signal is 0. Okay. Energy signal and power signal we write here in shortcut. Power signal both are mutually exclusive. मीन्स कोई भी गिवन सिग्नल है, या तो वो क्या होगा, एनर्जी सिग्नल या पावर सिग्नल, या दोनों नहीं होगा. ऐसा नहीं होगा कि वो दोनों हो. ओके, मीन्स म्यूचुअली एक्सक्लूसिव. The given signal either energy or power, but not both. Okay, this is clear or not, Abhishek? This is the property of a periodic sinusoidal signal is classified as a periodic sinusoidal signal is classified as energy signal, power signal, random signal, aperiodic signal. Tell me. Yes, power. Power signal. This is the sign of integration. Which signal is both even and odd? Tell me. See, yes. Okay, this is the right. Next. Which of the following is deterministic? What is the meaning of deterministic signal? First of all, we discussed here. If mathematical modeling of any signal is possible, then this signal is said to be deterministic. Otherwise, non-deterministic or any random signal. Tell me answer of that question. Deterministic signal? See, yes, 5 cos 2 pi t. Next, a deterministic signal can be represented mathematically exactly. Okay. As known as amplitude, frequency, and phase, noise signal are random and unpredictable. A random signal is also called deterministic, not stochastic signal, even signal, energy signal. This is the basic question here. Yes, stochastic signal. Okay. A signal defined only for discrete value of time is called. Very basic classification here. Tell me. A signal defined only for discrete values of time is called discrete time signal. Yes, you are right. Next. Which of the following is a continuous time signal? X of n equal to n square, x of t equal to e to the power minus t, digital signal, binary sequence. Continuous time, yes. B is the right answer here. Yes. A causal signal is one that exists only for t less than 0, exists for all the time, exists only for t greater than equal to 0. Tell me, what is the definition of causal signal? Yes, C is the right answer. Okay, so these are the 40 questions from my side. Okay, if you face any difficulty, then discuss with me. Okay, according to syllabus and all. And here we explain the syllabus of your CIL. Okay, here we discuss the syllabus. See, signal and system, signal and system. See, first of all, basic classification of signal like energy signal, periodic signal, non-periodic signal, and classification of signal also in the standard form like unit impulse, step response, ramp response, parabolic signal, okay, triangular pulse, and what type of question asked based on that particular topic. Okay, this is the chapter number 1. Next, classification of system like causal, non-causal, linear, non-linear. Okay, very important. And convolution we also study here in the part of system. Next, continuous time Fourier series. Continuous time Fourier series we write in the short way. Fourth chapter, continuous time Fourier transform. Okay, continuous time Fourier transform. Fifth chapter, Laplace transform. Very, very important. Next, six Z transform. Okay, this is clear now. Z transform. Next, 7 discrete time Fourier transform. 8 discrete time Fourier transform. 9, okay, FFT, okay, fast Fourier transform. Okay, 10 sampling. Then 11 filters. 12 some miscellaneous concept here. These are the area. But for electrical engineer in the CIL or any other PSU, there is no difference between the syllabus of electrical and electronics. Okay, see, again we revise these all the things we cover in our module. Okay, this is the next. And we discussed, first of all, we discussed the brief idea of the theory related to particular topic. Then we discussed the multiple MCQ based on the particular topic. Tell me if you face any difficulty. Abhishek, Madhuri, Sarthak, any doubt? Sir, will there be more? Yes, beta, we will plan. Okay, more session like and if you mention the difficult topic, then we take the session on that particular topic, na. But all the signal and system on the YouTube is not possible, beta. If you mention the particular things in which you face the difficulty, then we definitely take the session on that particular topic, na. Sarthak? Okay. Z transform. Okay, we plan on that. Any other? Any doubt? माधुरी क्लासेस चल रही है ना बेटा, क्लासेस आर ऑन गोइंग. ओके, बट अभी सिग्नल की नहीं चल रही आई थिंक ना, क्लासेस तो ऑनगोइंग है ना माधुरी? सिग्नल एंड सिस्टम की सर, हाँ यस बेटा, बहुत जल्दी। ओके, अभी तो आपका स्लॉट चल रहा है ना, बाकी तो चल रही हैं। ओके, पीडीएफ प्रोवाइड होंगे क्लासेस के, यस यार। ओके, जो एक्चुअली क्या होता है ना लक्ष्मण, मतलब कहाँ की बात कर रहे हो, यूट्यूब की या फिर पोर्टल पर जो क्लासेस चलती है उनकी बात कर रहे हो? सर, इज द गोइंग टू बी द डिफिकल्टी लेवल ऑफ CIL? No beta, this is the basic level yaar. In our first session we discussed the actually, see बेटा यूट्यूब की सारी पीडीएफ शेयर हो जाएंगी आपको ना, वो मैं ग्रुप में आप ज्वाइन कर लेना ना। ओके लक्ष्मण, सी डिफिकल्टी लेवल actually two paper 2017 and 2020. This paper we discuss on the same platform solution with solution, detailed solution. And this paper Chandrasekhar sir discussed in the detailed manner. But in both two paper like 2017 and 20, drastically change pattern. Okay, drastically change. Okay, here difficulty level is more. Here difficulty level is more. Here is less. But in today lecture we discuss all the things, average of that particular papers in 2017 and in 2020. We take the average and we discuss the things. Okay, Lakshman? Any other doubt? Okay. So we end the session. If you having any doubt, then please discuss with me related to anything. Sir, could you please tell where to practice problem? For self-study, Sarthak. Welcome, Madhuri. Thank you, beta. Sarthak, please mention the point clearly. If you are studying on the self-study mode, then this is different thing, na? Then this is also mentioned related to technical domain. But a self-study or okay, beta, you discuss with me, okay, on personal number, na? You can join the WhatsApp group and in which we also there. Okay, then we discuss all the things related to self-study or coaching, or how much questions you need subject wise, and what is the difficulty level, all the things we discuss in each every student. बेटा ग्रुप में ऐड हो जाओगे ना सार्थक, वहां से मिल जाएगा बेटा आपको नंबर ना। अभी यूट्यूब पे जाएगा ना सेशन, तो फिर नंबर ऐसे यार बहुत ज्यादा वो हो जाता है ना, आप वहां से ले लेना बेटा, डिस्कस कर लेना मुझसे फिर। ओके ओके ओके, ग्रुप में अगर हो तो आप वहां से नंबर मिल जाएगा मेरा ना। ठीक है, फिर इतने ही रखते हैं आज। ओके।